If you want to learn how to make a top-down dungeon crawler, something inspired by classics like Gauntlet and even Diablo, something that has path-finding enemies and area of effect explosions, something that was the beginning of my own dungeon crawler game, a top-down, couch co-op, action RPG with randomly generated levels and multiple player characters, then keep watching and I'll show you how. G'day gamers! Previously I released a tutorial for drag and drop users showing how they can make a simple top-down project which could be the basis for their own dungeon crawler game. Many viewers have asked for a continuation of that series, while others just want more GML content. Well, I'm going to do both by starting a dual GML and drag and drop tutorial series to cater for everyone's needs. So we need to get you GML users up to speed and set up with the movement and collisions so you'll be in sync with the drag and droppers come episode 2. So the first thing you want to do is create a new project. It's a new GML project. And I'm going to go up here and just change this to custom order so that we can sort our groups. Now we don't need all of these groups. I'm actually going to hold down Control and then select some groups that we don't actually need and press delete. And we'll also take that one and just clean that up a bit. Now the first thing I want to do is make the player. So I'm going to right click on sprites, go to create and go down to sprite. Now I'll just call this S_player standing for sprite. And by default, it is a 64 by 64 sprite. I'm going to change that to 16 and tab, press apply. And I'm going to edit that and we'll just set it to a nice blue color and fill this in. Now, as well as that, I can hold the middle mouse button to scroll and control and wheel mouse to zoom. And I want to set the origin to middle center, and that's the X and Y position of the player. Now we can close that down, go down to our objects, right click and create a new object. And we'll use our object to represent our sprite in the room. So this is O_player. And we want to take that sprite and just drag it and drop it over here onto the object. Now the first thing I want to do is create an event. Now each object has events that run in it, and these events run at various times. For example, I can make a step event which runs 60 times a second. And in here I can add some code to control this object. Now I want to capture some inputs that we can use to control where the player is going to move. So I'm going to create a function called get_input. Now, at the moment, I'm just calling the function. I'm not actually creating it. I'm going to go create it in the scripts folder. I'm going to right click and create a new script. And I'm going to call this player processes. And if I maximize that, we can see that a function gets created by the script name. Now, because I'm not actually going to call this player processes function, I'm going to delete all this. And we're just going to use this one player processes script to store all the functions for the player. And functions are just snippets of code that'll run when you call the name of the function. So we write function, get input, open and close some round brackets, and then open and close curly brackets, and then we write our function inside. So in here, we want to get the input from the player. And we can do that by saying if keyboard check, and that'll check if a key is being held down. And we want to look for ORD A, open brackets, close brackets. So make sure your A is in capital letters. And therefore, we're looking when A is being held down. And if it is being held down, I'm going to set left to equal 1. Now I'm going to duplicate this line 4 times. And I'm going to change the A to a D. And here to a W, and here to an S. So the standard WASD keys, but over here, when we're holding down D, we're going to store right as 1. And here we're going to store up as 1. So I'm just going to place these over here because it just makes it easy to read when they're tabbed across. And here we want to have down as 1. Now, when those keys are being pressed, we're setting these variables to 1. So if we go back into our player, I can hold down the middle mouse button to move. Those variables are being set to 1 when we're pressing those particular keys, but they never get reset back to 0. So we need to also reset them back to 0 each step. So I'm going to create another function up here, and I'm just going to call that reset variables. Now I've added a semicolon at the end of the line. That's good practice, and you should be doing that at the end of your lines as well. So if we go back into our player processes, and just above that, I'm going to add another function, and we'll call that our reset variables. Now you notice we get some yellow warnings here. All of that means is that these variables haven't been used anywhere else in your project. So let's just reset left to be 0, right to be 0, and up to be 0, and down. So back in our player, we are now resetting the variables every step because this step event runs 60 times a second, and each time it runs through, we're resetting the variables and then we're capturing the input. And what we'll then do is down here, we'll use that input to move the player. So the next thing I want to do is take that input and I'm going to calculate the movement of the player. So back here, we'll have another function called calc movement. Now we want to use this to move the player around the room. So the first thing I want to do is create a variable. So I use var, and I'm going to just have the variable as underscore hmove. Now var will create a local variable, which means when this function runs, this variable is no longer used. It doesn't get stored. It's only for this one running of this function. And it turns yellow to indicate that it's a local variable. Whereas these variables have turned blue. They are instance variables. They are always available to the instance that creates them. And when you create an instance variable, you don't need the var prefix. Now for our hmove, I want to store if the player is moving to the right or the left. And we can do that by just saying right minus left. And the reason this works is because when right is 1 and left is 0, so when right is being pressed and left is not being pressed, hmove is equal to 1. And when right is not being pressed and left is being pressed, then hmove is equal to -1. And in Gamemaker, if we add a positive value to an object, it moves to the right, and a negative value will move it to the left. So we can use this hmove variable to move to the right or the left. And similarly, we have our underscore vmove, which is equal to down minus up. And the same principle applies, except in Gamemaker, when you move down the screen, you're increasing your Y, and when you move up, you're decreasing your Y. So for our vmove, when down is actually being pressed, this is 1 minus 0. So our vmove becomes 1. So we're moving down the screen, increasing our Y. When up is being pressed and down is not being pressed, vmove is equal to -1. So we're decreasing our Y and moving up the screen. Now we need to look at those values and then move our X and Y position to indicate we're moving the player. So if our hmove is not equal to 0, or our vmove is not equal to 0, therefore we're pressing either left, right, up or down, then what we want to do is get the direction we are moving. And we can do that by using a function called point direction. And I'm going to create a local variable called underscore dir. So you'll notice my local variables all have an underscore. It's just a way that I use to know that that's a local variable. You do have the color changing as well, but historically it's just a way that I've done it so that I don't end up having a local variable and an instance variable as the same name. So we're going to say dir is equal to our point direction. And our point direction takes 2 points. So we're going to look at 0 and 0, and then our hmove and vmove. Now what this means is that if we take a point, say it's 0 and 0, and we look at the direction towards hmove and vmove, well, they're going to be between -1 and 1. And what that'll mean is that it'll look in a particular direction, like the 8 points of a compass. And that'll give us the direction from 0, 0 to that point. And that'll then tell us which way the player wants to move. So we can use that to say we want to get the distance we are moving. And I'm going to look at hmove, and I'm going to use another function called length dir underscore x. And this will take the length that we want to move and the direction we want to move in. So imagine that we're at this position and we want to move up to here. Well, what length dir x will do is work out based on that length and that direction, it'll give us the x component. So how far in the x-axis we need to move along to be at that point. So we can move along the x position, and then we can use length dir y to get the y part of that. So we'll have the distance in the x and the distance in the y, and we can use both of those to move to that position. So what's our length? Well, we don't have one yet. So let's just go back to our player. Let's add a create event, and I'm going to have a variable called walk speed. I'm just going to set it to 1.5. And we can use that as our length. So here we want to have walk speed as our length, and our direction is our underscore dir. Now I want to duplicate this line, so Control D, and if we press home, we can go back here and just change our H move to a V move, and we can change our length dir x to length dir y. So this will get the distance from our current point to the point we want to move in the x and the y directions. But we still need to apply it to our current x and y in order to move that distance. So now we can just add that movement to the player's position. And we can just say x plus equals h move and y plus equals v move. So now we'd like to test that out with the player. Now Gamemaker has rooms which essentially represent levels in your game. And at the moment there's one room already created for you. So if you double click that and open the room, by default, it's down here on the left, it shows you the size of the room. Now I want to change this from 1366 down to a smaller size of 360, and the height I'm going to change to 240. Now these are just values that will actually work well for the dimensions of monitors. Now if I run that, actually you'll see that the window that's created is very small. And there it is there. But what we can do is scale that up to make it easier for us to see. So under viewports and cameras, I want to enable viewports. And under viewport 0, we'll make our camera visible. So that creates this huge camera, which is actually currently the size of the old room that we had. But we want our camera just to be this small little area here. So here under camera properties, I'm going to change that to 360 by 240. And that will make a camera that size, but even if I run that, it'll still be the small window. We need to then scale that viewport up, and you want to scale it by a multiple of your camera to keep the pixels all in proportion. So I'm going to go from 360 and I'm going to multiply that by 3, and that will be 1080. And then we'll multiply this one by 3, and that'll be 720. So if we run that, then our small window will be scaled up to a larger size. Now what we're missing at the moment is we have no player in the room. So we can place objects in the room on instance layers. So we need to drag the player across and make sure you're dragging the player object, not the player sprite. And now if I run the game, our player should be able to move in the room. Great. Now let's add some solids for them to interact with. So let's right click over here and create sprite. I'm going to create an s_solid sprite. Go to edit and let's set it as a red color. Now if we click here, we can drop the opacity down or the alpha down, and then we'll fill in this area. Now the other thing we want to do is change this so we can resize sprite, and just make sure you set it at 16 by 16. Now I'm going to leave the origin where it is there, and we can close this down. Now we also need to make a solid object. So let's go to create objects and type in O_solid. Let's drag across that sprite. And that's all I want to do for that. We can close that down. Now if we go back to our room, we can actually start adding solids so the player can interact with them. Now let's make a layer specifically for the solids. So down here, let's create an instance layer. I'm going to press F2 on that and edit it. And this time I'm just going to call it collisions. Now each layer can have a different size grid that enables you to place your objects. So I'm just going to go up here and change the collisions layer grid to be 16 by 16. And now if you click on your O solid over in the room, you can hold down Alt and then you can drop that into the room. Now placing single objects like this might be a bit wasteful because when the player collides with them, they're going to run collision code on multiple objects. So instead of doing that, I'm going to Control Z and I'm going to hold down Alt again and just place the object there. And this time I'm going to drag it out like so. And I'm going to start placing them around like that and then just make a little room. So you can do something similar. You can also drag some in the middle there. So now if we run the game, we'll find that our player, when they interact with the solid, nothing happens. That's because we don't have any collision code there at the moment. So let's go back to our player and let's add a collision event with that solid object. Now the collision event will run the code in here each time the player and the solid are colliding. So in here, I'm going to add a function called collision. And then in our player processes, let's add our collision function here. And we'll just clear some space. Now, there are many ways to do collisions in GameMaker. I'm just going to show you one way to do it. I'm not saying this is the best way, but it's the way I'm doing it within the drag and drop tutorial. So I'm going to keep them consistent by doing the same method. And what that is if we go look at our room and we look at our player, let's say, for example, the player is wanting to move, I'll just turn the grid off, is wanting to move and they want to move down into this solid object. Well, we can't allow that. So if the player's here on one step and then the next step, they're going to move down to this position, that can't happen. And that means that the collision event will run at this point. So what I want to do is look at where the player wants to go, take them back to where they were the previous step, and then move them towards that position, 1 pixel at a time, until they can no longer move anymore because they're going to collide. And that means the player will end up as close to the solid as they can. So if we're going to go down here and move to this position, we'll take them back here and we'll move that 1 pixel at a time until we can no longer move anymore. So let's go implement that. So let's first set our target values. Remember, we're in a collision at this point. So our target X is going to be our current X, Control D, and our target Y is going to be Y. So these are the positions we want to move to. So now we want to move back to the last step position out of the collision. And we can do that by saying X equals X previous. GameMaker has an inbuilt variable that keeps track of the position the player was previously, but you can only use this in a collision event and a draw event. That's the only time it'll actually be true. In the step event, it'll actually equal your X and Y of that step. So let's duplicate that and have our Y previous as well. Now let's get the distance that we want to move. And how do we know that? Well, as far as the X goes, we want to move from our current X to our target X. So our distance of X is going to equal our target X minus our X. But the problem with this is that we could be moving left or right. We don't know which way we're moving. And if we're moving to the left, our target X is actually smaller than our X. This is going to end up being a negative number. So what we can do is take the ABS of this, which will ensure that this will always be a positive value. So let's duplicate that and do the same for our Y. So now we know how far we want to move in our X and our Y. What we can do is let's move as far as we can in the X and Y before hitting the solid. And we can do that by running a repeat on that distance X. So if this is 10, then 10 times we'll move 1 pixel at a time when we can. So we're going to repeat this. We need to check, and we say if, and we need to work out, can we move that 1 pixel? So if there is not a place meeting, and place meeting will look at 2 objects and it'll tell you if they're colliding at that particular position. So we're running this inside the player. So the player is going to look at a position and see if it's going to collide. So if there's not a place meeting at the position we want to move, which is our X plus that 1 pixel. Now, how do we know which way the 1 pixel is? Is it to the right or the left? Well, we can take the sign of this, the sign of tx minus x, and the sign will either be a -1 or a 1, depending on if this is a positive or a negative value. And down here, we're looking at, says x, y, and object. So that's our x. And we look at our y, and the object's going to be O solid. So if there's not a place meeting, if there's no collision, well, then we can move that 1 pixel. So we can say x plus equals the sign of tx minus x. So if this single pixel didn't cause a collision, then let's apply that single pixel to the player's X position, because we're allowed to. We didn't run into a collision. And we're going to repeat that for that whole distance. Now we need to do the same thing for the Y. So I'm going to select all of that, press Ctrl D, and we're going to change this to distance Y. And we're going to change this to X and then Y plus the sign of TY minus Y. So have a look what I've done there. Make sure yours is the same. We're just looking at our X and our Y plus the sign of TY minus Y. And our solid is the object we're looking at. And if there's no collision, then we want to say Y plus equals the sign of TY minus Y. Now, I didn't really go over what this plus equals means. Basically, what that means is you're taking the Y and you're adding something to it. So instead of saying Y equals Y plus 1, you could just write Y plus equals 1. And these two are the same. So instead of adding the extra Y, plus equals will take care of that for you. So now that we're flush against our solid, we can press play and test it out. So now when we move, we can move flush up against the solids. And even through these gaps, we fit perfectly through there. And also when we move along a wall, we can slide along the wall. We don't get stuck or anything like that. So let's just go back here and have a look at all this. If I actually comment this out, and we can right click and comment here. Now, if we play this, you'll see that this actually works just the same. And it looks like the same thing is happening. We're able to stop on solids. But if I could zoom in, you'll see that there is a gap that's being made when I move close to objects. Another thing is I can't slide along objects. I just get stuck on them. And very hard to get through a little gap like that when that happens. So what's happening there is we're moving back to our previous position, but we're not moving against the solid. So right here, there's a small gap. And if I increase the walk speed, you'll see that that gap gets larger. So depending on my speed, I'm being placed quite a long way away from that solid. You can see here, there's a huge gap. It all depends on the speed of your object. If you're firing a bullet or something, or a projectile, you'll see that the gap is quite large. So if I leave my speed at that high amount, we'll go back and we'll take off that comment, and now we'll move 1 pixel at a time until we're right against the object, and you'll see we don't have that issue anymore. So you get that alignment to be right where it needs to be. So I'm just going to go back and I'm going to change the speed back to 1.5 for our game. And that's your basic movement for a top-down game. This month I have these legendary Patreons to thank: Kazaho, Andy K, and Smash TRM. Also these epic supporters: Skydevil Palm, Salvatore Capolino, David Stylinger, Edward Lyko, Logan Animation 69, Paul R. LeBlanc, Robert Churches, Joachim Froholt, and Samuel Mui. Thank you to your support, I appreciate your generosity. I also run a course on Udemy, which is the highest rated Gamemaker 2 course on the site. Check out the trailer in the description, and I'll leave a coupon which will give you almost 90% off the retail price. In the next tutorial, we'll add some sprites to make the game look a bit better. Thanks for joining me, I'll talk to you in the next one.